Hi, everybody. Today is September 15th. You have homework to do and quiz one, right, everybody? And are you able to see the quiz in Blackboard? So go to Blackboard. The quiz is not in class. The quiz is online. Okay? So you can open your quiz like anytime within the day. Once you open it, you have 30 minutes to submit the quiz. Right, everybody? And I told you before, I set the setting to be unlimited attempts. So if your window closed, open the second attempt right away and attempt the image. Okay, everybody? Yes. And yes, do it before midnight. Okay. So today we continue on the continuity. I think we just missed two examples of this session. Then we will go to the 3.3 rate of change. Do you have the 3.3 worksheets? Okay, good. So last time we talked about continuity. Just remember one sentence. All functions we learned are continuous on the domain, right? So to find the x values where the function is continuous, this is the same thing as asking the domain, right, everybody? And domain, three things you need to remember. Do you see square roots? If you see square roots, the things inside the square roots need to be greater or equal to 0, right? Do you see fraction? If yes, your denominator cannot be 0. Do you care about the numerator of the fraction? Do you care about, no, numerator could be anything, right? If you see natural log, we need the things inside the natural log to be positive, right? Do you see, remember? Good. All right, let's continue. Part B. Okay, do you see square roots? Yes. Do you see square roots? Right, everybody? So we need the things inside the square root. Okay, so things inside the square root, we need to be greater equal to 0. Right, everybody? And do you see fraction? Fraction. Yes, we have a denominator, right? So because it's in the denominator, well, this is because of square root, and this is because of fraction. Okay. I mean not 0. Okay, let me put something here. Okay, because of fraction, we need the denominator not equal to 0. Is that okay, everybody? So when you combine them, think about it. This expression is greater equal to 0, but it's not equal to 0. Do you see you kind of delete the equal sign here? You only get greater than. Right, everybody? When you combine those two conditions, you only get greater than. So 2x squared minus x minus 6 greater than 0. Okay, everybody? Recall, how do we solve inequality? You move all the terms to one side, right? And you factor it, right? So let me see. Do I have something? Oh yes, it's the. Let me remind you. Okay, if you don't remember, go to your first week's worksheet. Okay. How do we solve inequality? Right? Move all terms on the left-hand side, and then you have set each factor equal to 0 to find the critical number. And then on each piece, you can pick a text point to plug in to see if it's positive or negative. And we have a second method where you look at the leading coefficient. If leading coefficient is positive, you start at the right upper corner. If the leading coefficient is negative, you start at the right lower corner, right? And for each root, if the multiplicity is odd, then you cross the x-axis. If the multiplicity is even, you bounce off. Do you still remember this? Yes. So we use these rules. Okay, so we factor. How can you factor? So 2x squared can be factored as 2x and x, right? How about minus 6? Minus 1 and minus 2 plus 1. 6. So either 1 and 6 or 2 and 3, right? Will 1 and 6 work? Yeah, minus, you mean here we put minus? Yeah, good, right. And then we multiply the outside. 2x times negative 2 is minus 4x. Multiply the inside, we get 3 times x. So that's why we add them together, we get minus x, right? Okay, so the critical number is we set each factor equal to 0. Oh, attendance. Okay, so we talk about the quiz today. Do it in Blackboard. Okay, so number 30 minutes. 1 or 2, depending on the student. Usually 2. And if you get logged out, open a second attempt right away to submit it. Okay? But if you use more than one attempt, please just email me and let me know what is going on. Maybe your internet's not stable, or maybe you take the time to upload it so long. So just let me know why. Okay? All right. So critical number is we set each factor equals 0. So for x, what's x? Blank? What's x?
3 divided by 2.
Plus or minus?
Minus.
Yeah, minus 3 over 2. How about the other one, Will? Yes. Okay, so we get the critical numbers. And then draw the real number line, right? That's the x. And label the critical number. So negative 3/2 and the 2. Okay, now we need to decide whether we put open circle or solid circle. So look at the inequality sign. Do you put open circle or solid circle? Yeah, open circle. So that's why we put open circle. Okay, everybody? And then if we want to use method 2, so 2 methods. Method 1 is test point. You pick those 2 points separate the real number line into 3 subintervals, right? So if you use the test point method, you each of the subinterval, you pick a point and then plug in the left-hand side of the inequality to see if it's positive or negative, right? But if we want to use the second method, then we look at the leading coefficients. So what is the leading coefficient? Yeah, the leading coefficient is 2. You see 2 is positive. So you start with the right upper corner. Ooh, like that. Or maybe. Let's see. Okay, so like this. Because do you see this is a square? It's a parabola. So you can imagine the graph is like this. Okay. And do you see 2? What's the multiplicity? multiplicity is 1, right? So that's why you cross. Similarly, negative 3/2, what's the multiplicity? It's also R, so we cross. Is that okay, everybody? And this makes sense. X squared, parabola, looks like a U shape, right? Everybody? So this is positive, negative, positive. What are we looking for? Positive or negative? Positive. Oh, so it's here or here, right? Dylan, can you tell me the interval notation? Mm-hmm. 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 You mean union? Mm-hmm. Mm-hmm. Yes. So we say f is continuous on this interval. That finished the problem. Okay, everybody? So find the intervals where function is continuous. It's the same thing to find its domain. And we know how to find the domain. Okay? Yes. So that's it for this type of problems. Okay.
So that's it for that question.
Yes, that's it for those questions. Because we want to find the x such that f of x is continuous. So like the first problem, because you don't see square root, fraction, and ln, you just continuous everywhere. Is that okay, everybody? The second problem, you saw square roots and ln. You have two inequalities. Solve for that. Draw the picture, and then you can get the interval notation. And this picture, and also this one is slightly harder because we have not just linear inequality, we have quadratic inequality. So you have to move all the terms to the left and factor. Okay, everybody? Good. Last problem in this session. Find the values of a and b such that the following function is continuous for all x. Do you remember last time we did this problem? We only have two p's and we only have one parameter k. You want to find the k such that those two p's meet, right, everybody? So instead of two p's, this problem just increased difficulties. You have three p's, but it's same idea. You want it to be continuous. So your first p is better to connect with the second p. It's better to connect with the third piece. Do you agree? So that's why here they meet at -3 and they meet at 2, right? So we want to make sure for -3, the left side of the limit and the right side of the limit match, right? And you also make sure for 2, x equals to 2, the left side of the limit and the right side of the limit match. So those are the two things we check. Okay? All right. So let's set up bless you, the interval. So we have 3 and 2. So 3 and 2 is what we check. So limit x goes to -3 from the left. So you want to figure out what is that. And also limit x goes to -3 from the right. You want to figure out what is that. And also limit x goes to 2 from the left. We want to figure out what it is. And the limit x goes to 2 from the right. We also need to figure out what it is. And here we have 3 formula. 1, 2, 3. Okay, I'm gonna ask you, hi Paige. X goes to -3 3 from the left, which formula do we use? The first one, right? Because it's less than -3. Yes. So use the first one. And remember always to write down your limits as long as you still have x in it. If you forget to write the limit, how many points I will take off? 1 point in the exam. Yes. So ax plus 2 e to the x plus 3. Okay? Don't think about 1 point is small. Think about every problem lose 1 point together. It's a lot. So get all the possible points you're able to. All right. What's the limit? We try to plug in x is -3 and see what happens. Right, everybody? When we compute the limit, we always plug in the number first. If we get something weird like 0/0, then we need to do more stuff. Right? So we plug in -3. And a and b are just constant, a parameter. Okay? So what do you get, Mackenzie? Yes. What's e to the -3 plus 3? E to the 0 is 1. Right, everybody? Oh, so you see, this is -3a plus 2. Okay, we get this expression. Next, Danny. When x goes to -3 from the right, which formula do we choose? -3 from the right. Which formula? The second one. Yes. Second one, x squared minus bx. And can you also tell me what do you get if you plug in? Yes, 9 plus 3b. Is that okay, everybody? All right. Good. Okay. Do you remember what we did before is we set those two guys equal, okay? But last time we also need to mention f of -3, right? Where do I put f of -3? Do I put it here or here? Where is the equal sign? The second one, right? So write down this guy also equals to f of -3. And then now you can set them equal. Okay, everybody, don't forget to write this down because the definition of continuous, you need the limit exists and you need the limit equals to the function value. So you have to check that. Otherwise, 1 point will be off in the exam. Okay? Alright, set them equal. So I get -3a plus 2 equals 9 plus 3b. Okay? So -3a plus 2 equals 9 plus 3b. Is that okay, everybody? Can we simplify them? Do you guys remember how to solve system of linear equations? Yes? Yes.
Wouldn't the 9 plus 3 be equivalent to 0?
No. F of -3 might not be 0. You just make sure the two side limits match, but it could be any number. It does not need to be 0. It could be 5. It could be -2. It could be any number. Just make sure they meet, but they not need to be 0. Okay? Alright, so set the left side of the limit and right side of the limit equal. And can we simplify them?
Yep.
Yes. How?
You minus the 2 and move the same values onto the same side.
Yes. Usually for linear, so if you solve like system of linear equations, you want to put like 5x minus 7y equals 11, maybe 2x plus 3y equals 5. Something like this. You want to have all the variable on one side and constant on the other side, right? And here, do you see this minus 3a is negative? So if you move to the right, it becomes positive. And so then you have a and b have positive coefficients. Okay? So it looks like it's better to move the 3a on the right and then move the 9 on the left. Okay. So add the 3a and also minus 9. So you get what? 3a plus 3b equals -7. I will think about that later because I know it will make the coefficient of a and b easier, but it will introduce fraction. Yes, because it's hard to work with fractions. There are many possible answers. So let's keep this for now. Okay, let's look at the other side. All right, down J. Okay. When x goes to 2 from the left, which formula do you use? Yes. The second one. X squared minus bx. If you plug in 2, what do you get? Yes. Yes, 4 minus 2b. Very good. You plug in x equals to 2. So b stays here. Okay. So sometimes you have to be careful. Don't plug in b is 2. Okay. B is just a number. It's not the variable. It's a constant. So leave the b here. Okay. Next, Joseph. When x goes to 2 from the right, which formula do you use? The bottom one. Square root of 14 plus x plus 1. When you plug in, what happened? Yes, square root of 14 plus 2 is 16. Square root of 16 is 4. So 4 plus 1 is 5. Right, everybody? Okay, now we have the left side of the limit, the right side of the limit. We know they must be equal, but we also want to say one of them equals to the function value at 2. Which one equals the function value at 2? Yeah, from the right?
No,
from the left, yes, this one. So this one equals f of 2. Good, now we can set them equal. Okay, so if you set them equal, what do you get? 4 minus 2b equals 5. Layla, can you solve for b? So here. So what do you do on the two sides? How do you solve for b? Move 5 over to the left, so you subtract 5. And then, what do you do? Plus the 2b. Okay, so the left-hand side, what do you get? 4 minus 5 is -1. On the right hand side is 2b. What is b? -1/2. So this problem, you get two equations with two unknowns you can solve. In this equation, you get the b right away, right, everybody? Then you can plug in the other equation and solve for a. Okay, now we can plug in. How do we solve for a? Blaine? Mm-hmm.
So it would be 3 halves, -3 halves. You do the reciprocal around the other side, or no, minus the 3 halves to the 7.
To the 7. So it is in subtraction. To get rid of that, you both sides multiply or add? Add. So get -7 at 3 half. Right? Common denominator is 2. What's -7? Negative. What's 21? Half. 7 is what over 2? 14 over 2. Yes. Okay, what's -14 plus 3? -11 half. Oh, what is A? What is A? Will. Huh? Let's try not to use decimal. Let's use fraction. So this is -11 over 2. That's 3A. So when you divide it by 3, what do you get?
Oh, -32.
Divided by 3.
Oh, -11/6.
Yes, right. So keep your answers in fractions. Just 11 over 6, if you use decimal, you get a long decimals. Okay, it's infinitely many digits of decimals. So, okay, finally we say if A is -11 over 6 and B is -1/2, then F is continuous everywhere. So this finished the problem. Is that okay, everybody? So we have 3 pieces. We make sure they meet, right? So they meet at 2 points, the -3 and the 2. So for each point, we make sure the left side limit equals the right side limit. So in this problem, you get those 2 equations and you can solve for B here. But other example, maybe on your exam or quiz, okay? You have 2 linear equations. How do you solve the system of linear equations? 2 methods. Substitution. Substitution is you find one of the equations and you solve for y in terms of x. Or you solve for x in terms of y. Then you plug in the second equation. So you get one equation with only one unknown. Then you can solve for that unknown. And then plug in the other one to find the other unknown. So this is the substitution method. The other method is elimination method. We use the elimination method. You look at the coefficients of x and y, and you want to find the least common multiple of the coefficients, right? For example, this one. 2, 5, do you want to work with 2, 5 or 7, 3? Which one is easier? Looks like 2, 5 is better than 7, 3. Do you agree? So here we want to eliminate x. Then you want to get the least common multiple of 2 and 5, which is 10. So your first equation, you multiply by 2. So you get 10x minus 14y equals 22. And the second equation, you want to multiply by 5. You get 10x plus 15y equals 25. Okay, so this is equation 3 and 4. Then you can get rid of the x, right? You can use equation 4 minus 3, x cancels. 15 minus negative 14 is, so minus negative 29y equals 25 minus 22. 3, right? So your y is 3 over 29. You can plug into one of the equations. Looks like this equation has easier numbers. You can plug in here and find x. So this is elimination method. Okay? So this problem is easy. We can find the b just looking at the second equation, and you plug in and find the a. But in general, if you get a system of linear equations, you can either do substitution method or elimination method. Is that clear, everybody? Mm-hmm. Good. And that's it for 3.2. So let's close that. Okay, and 3.3. Okay, so rates of change and definitions of the derivative. Suppose we are driving on a straight highway. If we pass milepost 100 at noon and milepost 130 at 12:30, we travel 30 miles in a half hour. Then our average velocity is the change of time, the distance over time, right? Distance we travel 30 miles. Then divided by half hour, so 0.5 hours. So 30 divided by 0.5 is 16 miles per hour. Right? This is the average velocity. But the instantaneous velocity is the speed indicated by the speedometer, varies from one moment to the next. Do you drive? Do you have driver license? Yeah, so you know the average speed and the instantaneous speed. If you look at the number shows on your right, yes. Okay, good. Let's look at the following. A rod is launched vertically outward from the ground with a speed of 96 feet per second, neglecting air resistance. The position of the rock after t seconds can be given by S of t equals negative 16t squared plus 96t. Find the average velocity between t equals 1 second and t equals 3 seconds. Okay, everybody? So find the average velocity. So average velocity is change of the distance over change of the time. Is that okay, everybody? Here, even though I gave you the picture, let's pretend the picture is not here. Okay? We can use the picture to check our work. But for now, let's pretend the picture is not here. So change of the displacement. You're using the final displacement. See, it's between t equals 1 second and t equals 3 seconds. So your final displacement is s of 3. Right, everybody? Minus your initial displacement, s of 1. Right? Over the final time, 3 minus the initial time, 1. Is that okay, everybody? S of 3. S is the displacement function. Did you take physics before? No, oh, do you need to take physics?
I'm in physics 2, or coming out of physics
Oh, okay. Right. So, you know, you have your displacement, and you talk about derivative yet? No, not yet. Okay. So we will talk about derivative later. But if you have displacements, you take the derivative, you get the velocity. You take the derivative one more time, you get acceleration. So this is the physics.
Yeah, we're using algebra trig for ours. We're
Oh.
not using calculus for ours.
Oh, okay. I see that.
Yeah.
Okay. Yeah, so maybe after this lesson, then you know how to find the instantaneous velocity. Right. So the average velocity is change of s over change of t. Now speed is distance over time. This one you know, right? Distance s of 3 minus s of 1. So the final displacement minus the initial displacement. Over change of time, 3 seconds minus 1 second. So let's figure out what is S of 3. So S of 3 is, this is S of t. S of 3 is you replace t by 3. Right, everybody? So S of 3, let's put it here. Okay, so plug in the formula. Negative 16 t squared becomes what? T squared, you plug in t is 3. 3 squared is 9. Right, everybody? So 9 plus 96 times t is 3. Yes. Minus s of 1. You plug in t is 1. So minus 16. What's 1 square? 1. Oh, well, you multiply by 1, it's just that thing, right? You don't need to write multiply by 1. Plus 96 times 1 is 96. Is that okay, everybody? Okay, maybe we don't need to practice it there. Okay. Denominator, what is 3 minus 1? 2. Right, everybody? Okay, now let's see. 9 times 16. 9 times 6, 54. 9 times 1, 9. 9 plus 5 is 14. So 144, right? Negative 144. 3 times 6, 18. 3 times 9, 27. So 288. Right, everybody? Minus, okay, what's 96 minus 16? 70? What's 9 minus 1? 80, yes. Oh, almost there. Eh, do you see 288 is double of 144? When you subtract 144, you have 144, right? So 144 minus 80. What's 144 minus 80? Yeah, over 2 is 32 miles per hour. Okay, everybody? So I suggest when you do your homework, try not to use your calculator. Okay? But if you get an answer, you can use your calculator to check it. But in the process of doing it, try not to use your calculator. Okay. So this is the average velocity. And you can look at the picture. So average velocity is like the slope. Do you agree, everybody? The slope is change of the y coordinate over change of the x coordinate. In this case, the x coordinate is the t, the time. The y coordinate is the s, the displacement function. So your slope is like the average velocity. Okay, everybody? And oh, you can see those 2 points. That's why this point is 3, comma 144. See, this is 3, comma, x of 3 is 144. And then this point is 1, comma 80. That's why our picture matches with our
Isn't the unit supposed to be feet per second?
Oh, you're right. Thank you. You're right. Thank you. Yes, feet per second. Sorry, I didn't look at this carefully. Feet per second. Yes. Okay, so this is example 1. Good. Okay, let's keep going. Alright, so consider a curve y equals f of x and a secant line intersecting the curve at the point a f of a. So a, and this is f of a, and the second point, let's say this is x, and this is f of x. Okay, so we have those 2 points. The slope of the secant line is change of y over change of x. So this is change of y over change of x. Right, everybody? In this case, change of y is the difference between them. So f of x minus f of a. Right? And change of x, do you see, is the difference between a and x. So we use x minus a. So therefore, the slope of the secant line is f of x minus f of a over x minus a. Change of y over change of x. Right? So this is called the average rate of change of f on the interval a to x. And now, let a be a fixed number, and let x be a variable. So x is changing. So let the second point getting close to the first point. So when this x moves to here, do you see the secant line is this secant line? Right? And do you see if x moves closer, do you see the secant line becomes this one? And do you see when x is getting closer to a, the secant line will converge to the tangent line. So this is the red line, is the tangent line, is the unique line through the point tangent to the graph. They only touch the graph at this point. Okay, everybody? So from this picture, we know that when we let the first point be a fixed point, second point varies, we let the second point getting close to the first point, the secant line passing through those 2 points will converge to the tangent line at point A. So that's why. What is the slope of the tangent line? The slope of the tangent line is the limit. That's why we learned the limits in the previous sessions. It's the limit. You let the second point goes to the first point. Then it's the slope of the secant line. Right, everybody? Aha! So limit x goes to a, f of x minus f of a over x minus a. So this is the formula of the slope of the tangent line. Okay? And this is also called the instantaneous rate of change of f and a, provided the limit exists. And now, because you have the slope and you have a point, see, this is a point a, f of a. And remember, we have slope, point slope form, f. Point slope form is y minus the y coordinate of the point equals to the slope times x minus the x coordinate of the point. This is the point slope form. Then we get the tangent line equation. So far, so good, everybody? Yes. So this is definitions, rate of change, and tangent line. There is another expression. Okay, so they mean the same thing. It's just we call the second point to be something else. So this is our picture, right? We call the first point to be A, then the y value is f of A. We call the second point to be X, then the y value is f of X. Okay, everybody? Now, let's call the second point to be A plus H. Okay, but it's kind of the same thing. You call the second point to be A plus H. So your first point, look at your first point. Your first point, you are letting X goes to A. But now look at your second picture. You want to have A plus H goes to A. Well, this is the same as saying H is going to 0. Do you agree? Your second point is like X, right? A plus H goes to A. It means your H goes to 0, right? So that's why your second point is A plus H, f of A plus H. So your secant line so is f of A plus H minus f of A. And you see the difference between those 2 points is H. Okay, so your denominator is just H. The good thing about this formula is your denominator is always H. Okay, when I change a different function, change a different A, your denominator is always the same. But if you want to use this picture, your denominator changes. Because if your A is different, maybe your A is 1, maybe your A is 2, your denominator changes. Okay? That's why we prefer to use the second formula. So from now on, I suggest you use the second formula. Okay? If you forget the formula, draw the picture. Write down your first point, A, f of A. Write down your second point, A plus H, f of A plus H. Then you know rate of change is change of y over change of x. And you let the limit h goes to 0. So this is how you get the formula. Okay, everybody? So today, remember to do the quiz and homework 2. Huh?
Right?
Yeah, quiz in Blackboard. Have a nice weekend. We continue next week. Okay, so.